Welcome to qnawire.
Our question wants us to show that at the center of a loop wire of side D carrying current I, that the magnetic field is 2 root 2 times mu naught I over pi D. Okay, so in order to do that, I went ahead and drew out the diagram of what we have here, where we have this loop that goes from point A to B to C to D, carrying current I going in the clockwise direction. So if you, using the right-hand rule, if you curl your fingers in the direction of I, the magnetic field then would be into the page. So since each side is length D, to the center there in the diagram that I drew is a distance D over 2. So what we can say here is that the length L to the center is the distance D divided by 2. And then you have these two angles that it would make here, angle alpha and beta, for just considering one side. So we can find the magnetic field from each side of this loop and then add them all together to get the total magnetic field at the center. So the angle alpha here that we're considering is going to be equivalent to the angle beta, and these are equal to 45 degrees. Okay, so we can use the formula of the magnetic field due to a straight wire of finite length for each side of these squares. And then, like I said, the field of all the sides is going to add, so you'll consider all 4 sides to calculate the total strength. So in general, the magnetic field due to a finite length, well, actually, why don't we write it this way? So the total magnetic field B is going to be the magnetic field of each side, right? B1 plus B2 plus B3 plus B4. So now we just need to find the magnetic field due to one side. So we'll start with B1. B1, the equation here is mu naught, the magnetic permeability of free space, times the current, which is I, divided by 4 pi times the distance L, or the length. But we said that L was D over 2 here, so this is going to be times D over 2. And then this gets multiplied by the sine of alpha plus the sine of beta. But we also know that alpha and beta are equivalent, and they're both equal to 45 degrees. So we can further simplify this a little bit. And we see that this is equal to, let's actually write it on another page so we're not pressed for room here. B1 is equal to, we have mu naught I still on top, divided by, we had 4 pi times D over 2. So this is 2 pi times D. And then we had the sine of 45 degrees. Let's rewrite that D, make it look nicer. We had the sine of 45 degrees plus the sine of 45 degrees. But the sine of 45 degrees is root 2 over 2. So we have root 2 over 2 plus root 2 over 2, which is just root 2. So this all gets multiplied by the square root of 2. And we can simplify this even further, because root 2 over 2, if we consider the square root 2 on top and the 2 in the denominator, root 2 over 2 is equal to 1 over root 2. So this is mu naught times I divided by root 2 times pi times D. So we need to do the same thing for B2, B3, and B4. But if you look at the diagram, the distances on each side, the length of each side is D, since it's a perfect square here. And alpha and beta are going to be the same. I is the same. So B1 is going to be the same as B2, B3, and B4. Just from symmetry of the problem. So B1 is equal to B2, which is equal to B3, which is equal to B4. So therefore, B here is equal to 4B1, right? Since if you add them all together, if they're all equal, it's just going to be 4 times B1. So this is 4 times mu naught times I divided by root 2 times pi times D. So we're really close to what we were asked to prove, but 4 over root 2 is the exact same thing as 2 root 2. So this is 2 times root 2 times mu naught times I divided by pi d. And this is what we were asked to show. So this is the solution to our question, and we can go ahead and box that in.